thought I'd give a little talk on number theory and divisibility test today for those students who want to understand a little bit easier how to tell if a number is divisible by 3, how to tell if a number is divisible by 4, and so forth. And so I'm Professor of Mathematics Chuck Newberg for those who don't know me. And so happy President's Day, and so let's warm up a little icebreaker here. And how does the math world remember these 5 presidents? So who are the presidents? George Washington, James Garfield, Herbert Hoover, Dwight Eisenhower, and Jimmy Carter. So let's go through there. So I want you to think about those 5, try to play a little matching here, and we'll go through the answers real quick, see who remembers which questions, who remembers any of these. I only knew about 3 of them myself, or 2 of them myself, so.
I got the last one, that's about it.
That's the one that started this talk, or this part. All right. So, who was a West Point graduate and college president of Columbia University? He was the first and most serious about expanding efforts in the STEM field: science, technology, engineering, and mathematics. Anybody know? Anybody guess?
Yeah,
You guess C?
I guess B.
D? Eisenhower? Very good. It was Eisenhower. So STEM's been around a lot longer than I realized, that term STEM. So a Naval Academy graduate who studied nuclear technology and physics. He tried to convert Americans to the metric system. Well, I knew this one for sure because I was during that time. Jimmy Carter. We were close, in the 70s, we were close to being on the metric system. He was a surveyor. He has a surveyor's license from the College of William and Mary, worked in complex geometry formulas. George Washington. Holds an advanced degree in mine engineering from Sanford. Helped the college build a stronger, that must be engineering and math and science departments. That's not my typo there. All right, so you're on the roll there, young man.
Is it Hoover?
That is Hoover. And then has a degree in classical languages from Williams College, developed a Pythagorean theorem proof while in college. Garfield, yep, James Garfield. He's actually known for the first modern day proof of the Pythagorean theorem. So, all right, so just a little presidential there. So let's go back through, since my slides are out of order here. So thought I'd talk a little bit about number theory and divisibility test today. So we'll make a quick definition of divisibility of whole numbers. Then we'll look at a couple of key divisibility theorems. And then we'll talk about the divisibilities for 2, 5, and 10. And then we'll talk about the divisibility test for 4 and 8. And then we'll look at 3 and 9. And then also talk about 6 and 12. So hopefully we can get through all of this today. So, all right. And so we just went through that. So let's make a quick little definition here and introduce us to some notation that we might not have been exposed to before. And let's let A and B be whole numbers. A is divisible by B if there exists a whole number Q such that A equals B times Q. So when you tell me that 3 divides 5, or 3 divides 15. Well, the reason why is because 3 times 5 is what? 15, and 5 is a whole number. 5 is an element of the whole numbers. So remember, we don't allow fractions, so there's no fractions involved today. So that's our basic terminology, and then our basic definition, and then we can say B divides A, and to shorten this up, because mathematicians are famous for hiding all the good concepts in notation, our notation for this is B with a straight up and down slash with the A. So this right here, 3 divides 15 to a mathematician would be just written like this here. 3 divides 15. So just a little bit of notation so that we can streamline some stuff and you don't have to learn that I can't spell any words. So, all right. So really quickly, let's just look at Common Core. Where's this topic aimed at? So We're in grade 4, operations in algebra and Common Core. Find all factor pairs of whole numbers in the range 1 to 100. So in 4th grade, we expect our students to master what? 1 to 100? Recognize a whole number as a multiple of each of its factors. Determine whether a given whole number in the range 1 to 100 is a multiple of a given one-digit number. So in 4th grade, we expect our students to know, is 91 divisible by 7 or not? And things like that. So it seems like college students should also have this skill. And it's a good skill to have when you're trying to factor things. So, and then eventually decide if a number between 1 and 100 is what, prime or composite. So this is what we do in 4th grade. So let's look at our big theory of divisibility. So our first test. If D divides A and N is any whole number, then D divides N times A. And I'll put this in English for us non-math people here. It says if a number divides a number, then it divides all of its multiples. All right, so I think we'd all agree that 2 divides 10, right? Why is that? Because 2 times 5 is 10. So what does that also tell me? 2 divides all of the multiples of 10. So 2 divides 100, 2 divides 1,000, 2 divides 20, and all of its multiples. All right, so that's an important thing to realize. If we know it goes into a number, we know it goes into all of its multiples. All right, so I was going to prove this, but I don't think I'm going to prove it. So I'd like to prove it, but I'll skip the proof of this. So let's look at the next divisibility test. Really, we're only going to look at 2 theorems today. And the second one comes in 4 parts. So let's say we have some numbers floating around. We're going to call them A, B, and D. And the following statements hold true. If D divides A and D divides B, then D divides what? Its sum. All right? And I used this today in my class. Let me get a better eraser. In my morning class, because we were trying to decide, does 4 divide 96 without division? Does 4 divide 9? Oh, this is a hideous chalkboard. Does 4 divide 96? So what did we do with 96? We split 96 up as 80 and 16, because I know 80 is what? A multiple of 4? Is 16 a multiple of 4? So 4 will divide the sum. So what did we conclude in our class today? 4 divided what? 96. And this is called a decomposition. We don't have to do division. We can just break the number apart and look at the parts. All right, so that's the first part. The second part, if D divides A and D does not divide the second number, then D does not divide the sum. So we also had to work this one today. And I apologize for this lousy chalkboard in here. We needed to decide, does 4 divide 94? Now, misconception is you look at the last digit, it's 4, so it's got to be divisible, right? But if we think about 94, what do I know about 94? I know 94 is what? 80 and 14. Does 4 go into 80? It does, right? Because 4 times 8. Or 4 goes into 8. Does 4 go into 14? It doesn't. So I know 4 what? Does not go into the sum. And so that's the second part. And then the third part is dealing with the difference. If it divides 2 numbers, then what? Also divides their difference. And if it divides one number and doesn't divide the other number, then it what? Does not divide its difference. So I want you to look here. And in my class, I always think of this way. We always have to have a pile that's a yes, an absolute. We have to know that it goes into the first number, and then we use the second number as our decider. If it goes into the second number, then it goes into the sum, or what? The difference. If it doesn't go into the second number, then it doesn't go into what? The sum or the difference. So if I want to decide, and I'm going to challenge you guys real quick. I want to decide, does 7 divide 91? So think about breaking 91 up, and you have to have one where you know 7 goes into it. So I'll give you a second to think about that. And you want an easy multiple of 7. You always want to have something easy. Well, what's a nice easy multiple of 7 is what? 70, right? 7 times 10. If I split 91 up as what? 70 and 21. Well, does 7 go into 70? Does 7 go into 21? So what do we know? 7 goes into that sum. So what's our conclusion? 91 is divisible by 7. We also know then it's what? A composite number. This is like the tricky one in 1 to 100 is 91. Students often think it's prime, but they forget about the magic 7. All right. So, and I was going, we've done some examples, skip over that. And I was going to do a proof of that, but I'm going to skip over the proofs today. All right, so let's talk about the divisibility test for 2, 5, and 10. And let's think about numbers for a second. Let me put a number up here. Let's put the number 4,321. If you thought about that in expanded form, that really means 4 times 1,000 plus 3 times 100 plus what? 2 times 10, and in this case, 1 times 1. All right, so all numbers have an expanded form. That's our place value system. So let's think about 2, 5, and 10. Well, 2 divides 10, right? 2 times 5. 5 divides 10, and what? 10 divides 10. So if we go back to that theorem, we want to break these numbers into 2 parts. A part that we know that the number goes into, and a part that we have to decide. I call that pile B. Well, let's look at the place values here. Will 2 go into 10? It will, so it'll divide into this place value because that's a multiple of 10. Does 2 go into 100? It does because it goes into 10, so it goes in there. It goes in this place value. The only place value that we don't know if 2 goes into is what? The 1's place value. We know it goes in the 10s. We know it goes in the 100s. We know it goes in the 1000s. It goes in all the higher place values. Likewise with what? 5 and 10. So what happens is this piece here is that A number. And then this piece over here is the B number. And remember, pile A had to be a yes. We know that's a yes. And this is the only thing we're not sure on. So what's the divisibility for test for 2, 5, and 10? They all are exactly the same reason. If a number is divisible by 2, if its units digit is divisible by 2, we only have to what? Look at the 1's digit. And in that case, it has to be what, class? Even. A whole number is divisible by 5 if the units digit is divisible by 5 because we know it goes in everything else. And the only 1's digit that's divisible by 5 is what? 0 and 5. So that's why all those work. And then how about 10? A number is divisible by 10 if what? The last digit's divisible by 10, and the only last digit that's divisible by 10 is what? 0. You know, if this last digit's 2, 2 does not what? Divide 10. The only one that 10 divides is what? 0. So the reason why 2, 5, and 10, we only look at the last digit because we know it what goes in all those other place values. So that takes care of 2, 5, and 10. So now let's go on to 4. Does 4 divide 10? It doesn't. Does 4 divide 100? Yeah, 4 quarters makes $1, right? So with 4, we know 4 divides 100, then it divides 1,000, then it divides all those other place values. So the 4s, we don't know about what? The last 2 digits. And then let's talk about 8, then I'll put these up there. Does 8 divide 100? Well, you'll discover 8 does not divide 100, but 8 times 125 is 1,000. So 8 divides 1,000 and all those other place values. So it turns out with 8, what do? We look at what? The last 3 digits. So let's put those theorems up there. And I'm sorry, rushing here a little bit. So I was going to, well, I did the proof. This is basically the proof that we do in my Math for Elementary class, a little hand wave proof. So we can't use the last digit. So a number is divisible by 4 if only what? The last 2 digits are what? Divisible by 4. And a number is divisible by 8 if only the last 3 digits are what? Divisible by 8. So we only have to look at the last 2. So let's take a number here, big number. 437829142. And I want to decide, does 4 divide this number? What do I look at? I look at only the last two numbers. Now your number sense may already tell you this, but if it doesn't, you could split 42 up as what? 40 and 2. Does 4 divide 40? It does. Does 4 divide 2? It doesn't. So what would our conclusion be? 4 what? Does not divide this number. So, and notice what I do. I broke those up there. So that decomposition is a pretty important one. All right, so now let's talk about 3 and 9. So first off, if we look at a place value, the powers of 10, does 3 divide 10? Nope. Does 3 divide 100? Nope. Does 3 divide 1,000? No. So let's take a more generic 4-digit number. I'm going to say it's A, B, C, D. And I'm going to rewrite that as A times 1,000. Actually, I'm going to shorten it up. We don't need that many. We'll just call it, we'll have a 3-digit number, A, B, C. And let's make that A times 100 plus B times 10 plus C. All right. And now we're going to rearrange this number. And we're going to rearrange it so part of the number we know that 3 goes into, and the other part we're going to have to look at. Well, I know 3 goes into 9, and I also know 3 goes into what? 99. So I'm going to split 100 up as what? 99 plus 1. I'm going to split 10 up as what? 9 plus 1. And then C, it's a 1, so I'm just going to leave it alone. Now, let's apply the distributive law. This would be 99 times A plus 99, A times 1, which is just what? A. Let's use the distributive law. This would be 9 times B plus B times 1 is what? B. And then let's put a C down there. All right, so I just broke up that 10, 9, and 1 because I know 3 goes into 9. Now let's just rearrange things. So I'm going to rearrange. This number is divisible by 3 and 9. This number is divisible, so I'm going to move them over here. 99A plus 9B. And then everything else I'm going to put right here. Well, we know this number is divisible by 9 and 3 because of the 99 and what the 9. Well, what is this? This is A, B, and C. That is what? The sum of the digits. And so what really happening here is I always think of it this way. When we're doing the divisibility test for 3, which I'll put up here, we're really looking at the leftovers of when we divide 10 by 1 or 3. So, all right. So the divisibility test for 3. A whole number is divisible by 3 if and only if the sum of its digits is divisible by 3. That's the sum of the digits divisible right there. And a whole number is divisible by 9 if and only the sum of the digits are what? Divisible by 9. So you add them up. And if it's divisible by 3, your conclusion is the number is divisible by 3. If it's divisible by 9, the number is divisible by 9. So let's take a number here. Let's take this number here. 1, 1, 2, 4. Oh, I don't want 3 there. Let's just do that one right there. So let's decide, is it divisible by 3? And what are we going to do? We're going to look at the sum of the digits. Let's add them up. 1 plus 1 plus 2 plus 4. Let's add those up. 2 and 4 is 6. 1 and 1's 2. So what is that? 6 and 2 is what? 8. I almost couldn't add there for a second. All right. Does 3 divide 8? Nope. So what's our conclusion? 3 what? Does not divide this number. All right. So let's do a different number. Let's do 4, 1, 2, 1, 1. And let's add those up. Oh, and I should have pointed out, 9 also doesn't divide 8, so 9 didn't divide that number. Let's add those digits up. What would that be? That'd be 4 plus 1 plus 2 plus 1 plus 1. That's 4 and 2, 6, 7, 8, 9. Does 3 divide 9? It does. So we know 3 divides this number. Does 9 divide 9? It does. So we know also what 9 divides this number. So we have a pretty easy way to tell for what? 2, 3, 5, 9, and 10. And if you think about it, that's pretty much all the numbers other than what number are we really missing there? 7 and 8. And 7 we decompose. The test for 7's too messy to really bother learning. I don't teach the test for 7. I don't even know the test for 7. Josh may have it memorized. I don't. I used to teach the test for 11, but it's too big a number. So, all right. So now let's talk about 6 and 12 real quick. So 6 I know is what? 2 times 3. So if I know 2 goes into the number and I know 3 goes into the number, then I know also what? 6 goes in the number. So how about if I know 2 and 6 go, does 12 go in there? Well, what do you know about 2 and 6? They have a common factor, don't they? 2 and 3, do they have a common factor? They don't. 2 and 6 have a common factor. So I think, I'll challenge everybody to turn on their number sense. I know it is a Monday. Turn on your number sense and see if you can come up with a number that's divisible by 2 and 6, but not 12. I'll give everybody about 10 seconds. Did you find one, Alex? Stacy? How about the young man of Josh? 18. It's like great minds. That's the same number I was thinking of, Josh. 18. I know 2 divides 18. I know 6 divides 18. But definitely 12 does not divide 18. So when you're trying to figure out tests for more complex numbers, these two numbers, they have to multiply to 12, but they can't have anything in common. Can you think of any two numbers who multiply to 12 and have no common factors? How about 3 and 4? If a number is divisible by 3 and divisible by 4, then it's what? Divisible by 12. So when you're trying to come up with what I call other divisibility tests, like deciding if a number is divisible by 15, you break that number down into what? Numbers that are factors of it, that go into it, and have what? Nothing in common. I'm kind of rushing that little piece. So let's put the divisibility test for 6 and 12 up. For 6, a number is divisible by 6 if it's what? Divisible both by what? 2 and 3. And 2, we look at the last digit. What do we do on 3 again? Add up the digits. A number is divisible by 12 if it's divisible both by what? 3 and 4. So it's just some basic divisibility tests. And the ones, most students already know what? 2, 5, and 10. They remember that one. The ones we wished our students also knew is what? 3 and 9. So they can quickly tell if a number is what? Divisible by 3, so we could factor out that 3 to make it a little faster. So, all right. And here we have a big number, 32,346. Let's decide if it's divisible by 2. Who would like to tell me if it's divisible by 2? Young lady in the back there, Lucy, is that number divisible by? And how did you decide?
The last digit, 6 is divisible.
Yep, the last digit's even, right? We only look at 2. How about 3? Do you got them added up, young man? What do the sum of the digits add up to? 18. Does 3 divide 18? So what would our conclusion be? 3 divides the number. And why we have 18, might as well talk about 9, right? Because the digits that says 9 divide 18. So we also know 9 divides that. How about 4? Well, what's the test for 4 again? We look at the last 2 digits. So take 46, break it into a couple of nice numbers. And one number definitely has to be a yes on 4 going into. And what would that be? 40 and what? 6, right? Does 4 go into 40? It does. Does 4 go into 6? It doesn't. So what would our conclusion be? 4 does what? Not go into this number. How about 5? The young gentleman back there wearing that stylish hat. Does 5 go into that number?
No.
No, and how did you decide that?
5, it does not end in a 5.
Doesn't end in a 5 or 0. 5 does not divide the last digit. Last digit has to be what? A 5 or a 0. All right. Now 6, what do we know about 6? It was 2 and 3. We already said 2 went in, and we already said 3 went in. So what would our conclusion on 6 be? Our conclusion on 6 would also be what? A yes. Then how about 8? What do we do on 8 again? We look at the last 3 digits. So let's take 346 and let's break it apart. I know we could do division, but let's, long division's so boring. If you want to do some short division, I'm all for some short division today, but no long division. So let's think of your multiples of 8 real quick. Is 32 a multiple of 8? 8 times 4, right? So I could think of that as 320 and what, 26, if I did that right. I did. 8 goes into 32, so 8 goes into what, 320? Does 8 go into 26? Think of your multiples. I know 8 times 3 is 24, and 8 times 4 is 32, so it doesn't go in there. So 8 doesn't divide this, so 8 does not divide this. So what's our conclusion? 8 does not what? Divide that number. And 9 we did with the 3. And how about the 10? What do we look on the 10 again? Last digit is what? 0 or a, last digit is only a 0. So it's definitely not divisible by 10. All right, so quick rundown of divisibility test. We would really love our students to know the divisibility test for 2, 5, 10, 3, 6, and 9. And that just makes things a lot quicker.